Hello, Honors Algebra. Mr. Lawrence here with your flipped lesson for the weekend of May the 4th. And let me say, May the 4th be with you. All right, this is problem 9 off your worksheet. I know you don't have to do problem 9, but I want to do it as a good example. We didn't really get enough time to practice in class today. I apologize for that. And some of you had more questions than I was anticipating, and that's fine. I don't mind you asking questions. And we're doing okay on time, so if we need to slow down just a little bit, we're okay, provided we don't have any snow days or anything for the rest of the year. Anyway, excuse me. I'm going to take a look at problem 9 here, and I know two good ways to solve this. The first way is to cross multiply, okay? And so that would give me the problem of x plus 2 as a quantity times the quantity of x plus 3. And then, of course, I would have 10 times x. It's pretty simple. This is a good way to do this problem. I don't like it on the next type of problem I'm going to show you. I think it's more work, but that's only a personal opinion. But if you want to set it up to cross multiply, it's not a wrong way to do it. Okay, so I'm going to FOIL the left-hand side. I'm going to get x squared. I'm going to get a 5x for my outers and inners, and I'm going to get a 6. And then, of course, I have a 10x. And Mr. McLean can tell you that that is a quadratic, and so therefore I want the 10x. I want it to equal 0, and so I'll subtract 10x from both sides. Okay, and now I will end up with x squared minus 5x plus 6 equals 0. I could use the quadratic formula, but I'm such a factoring fool. I notice that this will factor nicely. I need two factors of 6 that add to get negative 5. Right? Well, they're both going to be negative, and I'm going to get a 2 and a 3. Oops, not a 2 and a 5, Mr. Lawrence. A 2 and a 3. So I know that x will have to equal 2 or 3. I'm going to go back and check my restrictions. I look up here at the original problem, and I notice that x is not allowed to equal negative 3. I did not get that as one of my solutions, so both of my solutions are valid, and I'm good to go. All right, let me try a different way to approach this one. And on this problem, it might not make as much sense, but you will see on the next problem why I'm choosing to do this. All right, I'm going to identify my LCD, which is going to be 10 times the quantity of x plus 3. I'm going to multiply this fraction by 10 times the quantity of x plus 3. I'll write it as a fraction. And over here, I'm going to multiply by 10 times the quantity of x plus 3 over 1. Okay. When I do that, on the right-hand side, the x plus 3's will cancel, leaving me with a 10x. And then over here, the 10's will cancel, leaving me with the quantity of x plus 3 times the quantity of x plus 2. And you can see now that it's the same exact problem from this point on. Okay. Subtract my 10x, and I'll end up with x squared minus 5x, plus 6 equals 0. And I'm not going to factor it again. You already saw that. X will equal 2 or 3. Excuse me. And my restriction was negative 3, so both those answers work. Okay, so let's look at one where I personally don't think it's a good idea to cross multiply. Okay, I would look at this one, x minus 1 over x plus 3 plus 4 over the quantity of, over x squared plus 5x plus 6, and that equals 1 over x plus 2. Now, I can't cross multiply this one yet. If I wanted to do the cross multiplication method, the first thing I'm going to have to do is I'm going to have to add the left-hand side of this fraction together so that it's one fraction, of this equation. So I go looking for my LCD, but I'm only looking at the LCD of these two terms. Okay, maybe I should do it this way, LCD over here. So I know I'm going to have an x plus 3 as a quantity because of that guy. I know that this factors as x plus 2 as a quantity and x plus 3, and so that guy's covered. So then I need an x plus 2. All right, so I'm going to multiply this by x plus 2 and by x plus 2. And my numerator of the left fraction will become x squared plus x minus 2. And then I'm going to have this plus 4 over here. And then that is all over the LCD. Okay, that'll still equal 1 over x plus 2. Now I have to combine these two terms and turn them into positive 2. They're like terms. Okay, so I'll make that a positive 2. Now if I want to, I can cross multiply. I don't want to cross multiply. I think it's ugly. I think it's hard in this kind of situation. But some of you will like to do it, so I will demonstrate how. Now this one is easy. I'm going to get x squared plus 5x plus 6. All I did was refoil that and then multiply it by the 1. Okay, but over here, I've got that trinomial times that binomial, which means I'm going to have to distribute the x all the way through. So I'm going to get x cubed plus x squared plus 2x. And then I got to distribute the 2 all the way through. So I'm going to get plus a 2x squared plus a 2x plus a 4. And then I need to combine my like terms, so the right-hand side is going to look like this. Now, mind you, with the way I'm going to do it, I'm going to get the same problem that you are getting, but I like my way better. But that's okay. X squared plus 5x plus 6. It's good to have a wide variety of tools. Oh, I don't know why I'm rewriting all that. Well, that's a cubic. You guys don't know how to solve a cubic. Not yet, anyway. Well, you might know how to solve this. I've got one idea, but I'm going to get everything equal to 0, just like in the quadratic. And so that'll become 0. And I'm going to subtract x squared here, subtract 5x here, and subtract 6 there. All right, x cubed plus 2x squared minus x, and then minus 2. And there's 4 terms there, aren't there? We've been factoring a lot. I think I'm going to do a grouping problem. So I'm going to group the x cubed minus x together, and then I'm going to put the 2x squared with the negative 2, and I'm going to GCF the first quantity and get x times x squared minus 1, plus I'll GCF the second quantity, x squared minus 1, and then I'm going to GCF out the x squared minus 1 because it shows up as a factor of both groups, x squared minus 1, and that'll be times what's left, an x and a positive 2. Okay, so then we have, oops, I'm not in right mode. We'll have a quantity of x plus 2, and that equals 0. Now I'm not done factoring. This here is the difference of perfect squares, so I'm going to get an x plus 1, an x minus 1, and a quantity of x plus 2. So actually, that worked out pretty good. I know that x is going to have to equal negative 1, 1, or negative 2. I better go back and check my restrictions in the original problem. Looks like in the original problem that it would not be okay for x to equal negative 2 or negative 3. You're welcome. Have a good night. All right. Sorry about that. I was talking to a student who came in to get some paper. And let me look at my answers. X negative 2 cannot be one of my solutions because it's a restriction. So there we go. Okay. So that's not so bad. But let me reapproach it here. And show you how I would have done it, and you can decide which way is best for you. All right, got to do some magic, make it all go away. It's not going away. There it goes. I just thought that really looked cool as it all disappears at high speed. Make sure I don't do too much. Okay. First thing I'm going to do is I'm going to find the LCD of all 3 terms. And again, I want this factored the factored form of x plus 2, x plus 3, both as quantities. And I see that my LCD is going to be just that, x plus 2 takes care of that guy, and then I need an x plus 3, and that'll take care of those two guys. All right, now I'm going to go ahead and multiply by the LCD all the way through the problem. So I'm going to multiply by an x plus 2 and an x plus 3 right there. I'm going to multiply by an x plus 2 and an x plus 3 right there. And then I'm going to multiply by an x plus 2 and an x plus 3 right there. Okay, here's why I like it so much. In the fraction over here, the x plus 2's cancel. I'm left with 1 times the quantity of x plus 3. So I'm left with x plus 3. Okay, in the middle here, this x plus 2 cancels with that x plus 2. This quantity cancels with that quantity. I'm left with a 4. All right. On the left-hand side, the x plus 3's cancel, and I'm left with an x plus 2 times an x minus 1, both in quantities. So I'll have to FOIL, which will be an x squared, 2x plus, oh, I'm looking at the wrong place. Sorry about that. I am going to get an x squared, but then I'm going to get a plus x, and then I'm going to get a minus 2, I believe. All right. That to me looks a lot less complicated than what we came up with before. So I'm going to combine some like terms here. I feel like I've made an error. Let me check my FOIL really quick. Hold on. Okay, I must not have made an error. I'm doing okay. Maybe it's just coming out so pretty that it's seeming like I made a mistake. So this will equal x plus 3. All right. Now, I'm going to subtract x and subtract 3 because I have a quadratic. I'll subtract x and subtract 3. And I find this really kind of cool. I get x squared minus 1 equals 0. And when I did it the other method, I came up with a false root. Right? I came up with that one number that was in the restrictions. And when I do it this way, that number that was in the restrictions didn't show up. And that's got me intrigued. I'm not sure why that happened, but I think that's really cool. If you follow what I'm doing, that would be pretty neat. I don't know. I'll have to think about that a little bit. All right, so that's how I would approach it. I find my LCD and multiply through by it. I'd rather do that than add fractions together. These fractions get pretty ugly. To me, this seems like a lot less work. But you pick the way that you like best. All right, Mr. Lawrence signing off. Have a good night, everybody.